Good morning, everyone. Today we're going to cover the next part of quality attributes. We're going to cover interoperability and modifiability, and if we have time, also performance. But first off, I would like to ask you if you have any questions on the course so far. Are the assignments going well? Some hesitant nods. Have you started with the assignments? Like the reverse engineering kind of design thing? Yes, I see some shy nods. Okay, that's good. That's good. It takes a little bit more time than you'd expect, I think, because at least if you have a relatively large project. Oh, this is going to be annoying, isn't it? Let's see if I can tuck it in here. And you also want to get started on the development as soon as possible. So if you can get done with the first part, then you can continue with the next part quicker. Any comments on the lectures, on the content so far? Something that I can improve for the coming? Because I have this is halfway in the course, I think, lecture-wise. I think I had 10 lectures, and this is the 5th. You weren't prepared for these kind of questions this morning, were you? It's all right. You can email me if you have any comments. You can even set up an anonymous account if you don't want to be recognized for who you are. It's okay. I'll take anonymous criticism as well if you don't want to sign it with your name. I'm doing this for you guys, right? So I want my lecturing and the lectures to be as good as possible and as pedagogical as possible. There are some limits to how much time I have to prepare and changes I can do, but if there's something I can do within the frame of time I have, I'll certainly try for the remaining lectures. Anything to improve this course from previous year, and the next year I'll try to improve it from this year. So, yep, okay. Interoperability then, if this works. There we go. So I'm going to keep doing the same setup as I did for the previous one, for availability. So basically just describe what it is and some give you a general scenario. We're going to have some discussions as well, and the tactics, and then the checklist in the end. So what is interoperability? Have you seen the original Independence Day movie? So some of you nodding. So there's a very interesting piece here where the alien computer is obviously talking Appy Talk, which is awesome. And it understood human-created computer viruses, which is also pretty awesome. And it could be infected by human-created viruses. So anyways, that's interoperability, being able to communicate with other systems or services or components, right? How they can use exchange information or meaningful information in a useful way. So basically, in simple terms, exchange information and access services. That also includes finding services. So, okay, Bluetooth being a communication protocol, right? You have this entire service discovery protocol. And I know how that works because I had to implement one for Bluetooth in version 0.9 or whatever. I used the Ericsson development kit, and the service discovery protocol was a bit buggy, and I implemented it from scratch, which is interesting. That's how I learned programming, by the way. 1,000 lines of code without compiling once and then trying to fix it. I was not a good programmer back then. Okay. So we're going to start off with a little exercise, and I'm going to use Google Mail as an example because it's such a large thing that covers so many different parts. So I would like you to 2 and 2 or 3 and 3 discuss or consider interoperability issues for Google Mail. Like, what parts need to be interoperable is one thing. I will give you some examples later on if you don't come up with any. What might be the potential problems with this interoperability? Why are these problems? So focus on like one at a time. So if you come up with one potential problem, discuss then why is this a problem? What are the consequences of this problem? And would standards help solve this problem? Or is there another solution or another need? So let's take a few minutes discussing this. Okay. Any suggestions? Yes, in the back. Drag and drop feature for files, certainly. And why might there be a problem with interoperability here?
Say you have three large operating systems, and then you've got a multitude of different browsers on that.
Yeah. So several different browsers and different tools to be compatible. Yeah. And what are the consequences if this doesn't work?
It doesn't work for some people.
Yeah, so it might not work for some people. I'm repeating now for the recording and for the people in Skellefteå. So it might not work for some people. And if you interpolate this problem, it will be frustration for certain users. People will not be able to collaborate. Some people, I mean, customers, in this case, Luleå University of Technology actually is paying for Google services. So if suddenly we wouldn't be able to use it, we would actually have to, we would have a we would have a support issue. There would be extra services put in, extra time to support this issue and fix it later on. And we would have to modify the code, which means developers would have to go in and so on. So having working interoperability from scratch is very helpful, or I mean, because fixes later on in the software is time consuming and costly, right? So thinking about these things from start is very helpful. And in general, for this entire class, are standards sufficient to solve this particular problem? Anyone? I would say to some extent, right? Because there are standards for how web browsers should handle files, right? So as long as they implement the standard, as long as Internet Explorer and Chrome and the WebKit browsers and Opera and what other, Mozilla. So those are the four main ones, right? So as long as they all implement the same kind of file handling system dialogues, it should work properly. But we all know that whenever it comes to plugins and tools and whatever, they don't always, they don't only use the file handling dialogues and stuff, but other things as well, typically. And it may not always work, and then we always also have the formats of the files and stuff like that. Like line breaks and stuff. I don't know if that's much of a problem in web, but in text files it could be problems. I know. Like whatever character encoding is in the files and stuff. Any other suggestion of interoperability issues? Work on different mail clients, certainly. And I will even go and extend this, because Google Mail can also handle IMAP servers and stuff. And you can actually, I can reply to your email via my Google Mail account, but with the LTU server, right? I could send as Luleå University of Technology as my sender or receiver. And I forward all my email to Google Mail. So it has to be able to log into an IMAP server somewhere in that case. And again, different mail clients, people don't always use the web client for Google Mail. They have their own mobile app clients and different operating systems there as well. And again, the potential problems, these are problems, of course, because I mean, you want people to be able to develop their third-party clients in this particular case, because it is an open software. You want to support all operating systems. Different software, Outlook important, yeah. So the consequence of these problems, well, in Google Mail, one of their selling points is that it works everywhere. It has good backups, good accessibility, right? Availability is perfect, very little downtime. And if suddenly it didn't work on all clients, say it didn't work on Linux machines, or it didn't work on iPhones, people would select some other mail client, right? So in this case, it's actually a big selling point. And standards, well, standards for IMAP, of course, that solves many of the problems. Standards for, I don't think actually there is standards for how the mail client should work, apart from the protocols to check emails and send emails and stuff. But I mean, a mail client is more than that, right? So I think there is an API mostly, right? And I suppose that is kind of like a standard. At least it's a protocol to use. Okay, let's continue. So just looking at this whole source, stimulus, and environment and stuff like that. So in this particular case, in the book, they suggest that the source is some system that wanted to interoperate with some other system. And then there's a stimulus, there's a request to exchange information of some sort. In the environment, while in the system wishing to interoperate or are discovered at runtime or known prior to runtime. So basically, either it's a discovery service or a listed service, or you know beforehand that these are the systems that I'm going to interoperate with. Responses. So basically, services are requests are rejected, or they are accepted, and requests are logged, etc. And how we measure whether we have an interoperable system, well, some percentage of information is correctly processed, and some percent of information is correctly rejected. So you can actually measure those things. How many requests for information do we handle per day, and how many are successful, etc. I might just read this scenario out loud. Our vehicle, so this is a kind of a scenario how different systems are interoperating. So our vehicle information system sends our current location to the traffic monitoring system. The traffic monitoring system combines our location with other information, overlays this information on a Google map, and broadcasts it. Our location information is correctly included with a probability of 99.9%. So this kind of covers like several systems that are meant to interoperate and combine information. We also have like the metric of how we measure whether we actually achieve this or not. So this is how you can describe such a scenario. I'm not going to have a discussion for tactics on this particular case because they're fairly simple. So I'll just go through them. So basically the tactics, the things we can actually do to achieve interoperability. And you might actually know other things. So these are just a few examples. There may be other things that are not covered here. But basically you need to have some service of getting services to get to know each other, like a discovery service or some list of different services available. We need to be able to exchange information in a meaningful way. So we need to have the same way of interpreting data. We need to have some protocols, some API or whatever. We need to provide information in correct sequence. We need to be able to modify the information to fit. So I developed, I think I used it in the previous course, this whole positioning technology, or maybe I used it in the design patterns part of this course. So some positioning technologies in a framework where we have Bluetooth positioning, Wi-Fi positioning, GPS, mobile positioning, etc. And they all use different coordinate systems. And we all use lots of different clients, etc. But we want the systems, the different positioning systems to communicate, and we want to be able to treat the positions in the same way. So in this case, we make modifiers for the positioning data. So some of them use WGS84, some of them use RT90. WGS84 is the regular one for GPS. RT90 is like a Swedish positioning coordinating system, which basically maps Sweden itself in XY in meters, which is very handy if you want to do triangulation because you don't need to do anything with it's like just meters anyways. But it's not accurate for the entire world. So we need to make translators between these coordinate systems. So that is one way of modifying the information to fit the client so they all use the same base whenever we communicate. Okay, some tactics. As you see, they are fairly simple. You need to be able to locate the service. So there are discovery protocols, there are service discovery protocols, or there are lists. There might be a directory somewhere where you can look up maybe a database of possible services, etc. And then manage interfaces. Orchestration is basically where you have kind of like an intermediary where that handles or coordinates information from a lot of different small services. So service-oriented architecture, SOA, uses this where you can combine information from a number of different services, web services, for instance, combine that into complete package and communicate. Then tailor interfaces is basically what I said. You can create a custom interface for the underlying structure to hide complexity, to hide implementations, and create a common interface that is like a standard or whatever, where you communicate. And if you have a directory service or if you have like a service discovery, typically you dictate the interfaces that you have to adopt to, and then all the implementations would tailor their interfaces to fit this. Does it make sense? Okay, good. Then we can skip these. Okay, so interoperability, I'm going through this fairly quickly. I think it's a fairly simple quality attribute. If you have questions, just stop me. Okay, So I'm going to go through the checklist quickly, and I did as I did with the availability one. I shortened them a little bit and focused on the most important parts. So allocation of responsibility. Basically, you need to find out what parts of the system need to be, need to interoperate with something else, right? That makes fairly good sense, I think. But you also need to implement functionality for accepting or rejecting requests, something that we saw in the whole source stimulus page. You need to, of course, have ways of interchanging or exchanging information. So someone needs to implement these things, right? So it's not just to say, oh, but this interoperates with that one. Well, how do you accept the requests from that service over there to actually do something and exchange information? How do you reject it? How do you notify a system or a person that the exchange is happening? Do you have a logging service for this exchange of information? Things that you need to consider, but it's fairly obvious, I think. But it's good to have the checklist regardless. Coordination model. Even though it's a very central part, like coordination model, whenever you interoperate, is of course central because it's coordination and communication, they all kind of go hand in hand, right? But it's fairly simple what you need to do. I mean, you need to have some protocols, you need to have some underlying networks, etc. Things that may not be as obvious, I guess, is that whenever you interoperate with another system, whenever you actually build this into your design, when you need some other components somewhere, you need to also consider how does this affect other quality attributes in my product. So if performance is a major issue, right? Imagine that you need to have certain quality of service or whatever. Then if I start connecting to other systems, can I ensure that those other systems fulfill the same quality attributes? Do they fulfill the same requirements? Do they run their systems in some form of concurrent system? Do I have message jittering, like messages appearing in different orders and stuff? Do messages appear in a timely fashion? So that happens whenever you build in reliance or support for third-party systems. You need to consider, well, what happens? And that same goes with security. So the moment I start connecting with a third-party system, have I safeguarded my own private or the sensitive data? What can they access, etc., etc. So consider that for coordination. Data model. Of course, syntax and semantics is very, very important. But again, that's what protocols are for. Translation of data formats, etc. I already mentioned this, coordinations, the coordinates, RT90 and VGS, so WGS84. I added encapsulation here, and what I mean is basically what data do I expose? And if I have a third-party system again, do I actually encapsulate data that is supposed to be private? Do I consider that? What data is made public and so on. And architectural elements. First one, I guess, fairly simple. Just make sure that the components that are supposed to be interoperable, they actually can reach the network. I suppose it could happen that, whoops, this is behind some form of whatever, firewall or something. This was in the book, so I imagine that this has actually happened for people. I think that if I designed a system that, well, this component is supposed to communicate with some sort of third party, I would give it access, but suppose some bugs can happen, I guess. Okay, again, whenever you have lots of distributed systems, you need to consider other quality attributes, so like security, availability, performance, and so on for all the communications. And resource management. So these are my limited resources. The critical limitations. I only have so much bandwidth to my system, or so many connections, or the database can only handle so many requests per minute or second. So whenever you connect third-party systems, you want to avoid them spamming your requests, etc., right? You know, make sure that they can't exhaust critical system resources. If we do have time to cover performance today, then I'll cover this as well a little bit, because it is a performance issue, right? And of course, some policies of how to relate to or how to use the shared systems. Some agreements, some APIs, some interfaces, some you know, what's allowed and what's not. When should we accept and when should we reject a request? Binding time. So this is when we have like polymorphism, etc., or we bind a system at runtime. So we need to know what systems may interoperate. When are they actually known to each other? Like, when do I bind them? Do I bind them at when I start a system, or can they be added as part of a communication request or something like that? What's the policy for this? The mechanism I use for discovering these services, how much overhead is there involved? Are they flexible enough? Can they be modified? Are they secure enough, etc.? Choice of technology. Of course, there's going to be frameworks and there's going to be hardware, etc., that has better support for interoperability than other things. I mean, if you look at web services, there are lots and lots of frameworks that make it very easy to be interoperable because they have clients and servers for all sorts of operating systems, etc. And they're all already built around interoperability, right? So I think the choice of technology, it's worth spending some time just finding the right framework or the right middleware or the right, you know, technologies to use. It could even be something simple as the choice of hardware technology or communication technology. Like, if I'm going to design something with a low energy communication, I would probably pick Bluetooth low energy or Wi-Fi, even though Wi-Fi is typically not low energy, but because I know they work on all platforms. It's such a established technology. I would probably not use Zigbee, even though that has existed for ages, but because I can't count on the drivers existing on all platforms, I guess. So that actually also affects things. Like, I don't know if there are any Zigbee on mobile phones ever. Like, might be add-ons or something like that. But I know Bluetooth low energy is available on like all new technologies, kind of. So, or even just regular Bluetooth. Okay. Yeah, what parts are visible? Yeah, and what consequences do they have to other quality attributes as well when you choose technology that's supposed to be interoperable? So whenever you pick a framework, does that actually affect something else as well? Like, if I pick a really flexible and interoperable like web service framework, do I also get lots of crappy security? I mean, it could happen. So it does affect other things. Of course, I could ignore using it, those parts, I guess. But preferably, you want to have if you pick a framework for something, you want to use as many parts of it as possible, I guess. Okay. It's probably going to be a shorter lecture. I don't think I'll do performance today because you're going to get the information overload. So let's do a slightly shorter lecture instead and have a break now. 5 minutes. Okay. Okay, before I continue, I got questions about change to a feature request during the break and size of, etc. It's very difficult for me to say exactly what kind of size issue in terms of lines of code, etc. that you pick, because it varies so much based on like how difficult is, how complex is the code, how long time does it take to actually find where to make the fix. So I've had groups doing one line of code in the end, but it took a long time to figure out what that line of code should be and where it should be. Like, so I usually, there are two things that I usually put as like a guideline. First thing, which is very subjective and you have to determine for yourself, you should learn something, right? That is my first requirement. You should make sure that you pick an issue where you feel like when you've implemented it, you've learned how to deal with the system, how to work with large pieces of code, how to investigate, etc., etc. So that is for yourself to determine, did I learn something by doing this? Second one is, like, rather than saying how large the issue should be, I usually say how much time should you spend on it. And I usually have a guideline 16 to 24 hours per person, something like that. And if you're a group of 3, then of course that'll be a larger issue, but it's not linear, because like 4 to 8 hours is going to be spent doing the same thing by everyone. Everyone needs to understand where and so on, right? So the first part is like the same. You all waste or spend 8 hours doing the exact same thing, trying to understand things and figure out where and stuff. But the implementation part might be slightly larger than if you're several people. And I think if I heard as a student like, oh, 16 to 24 hours, I would be slightly nervous, because that sounds like a long time, or maybe it doesn't for you, I don't know. Like, that's 3 working days, up to 3 working days. I think it's very quick to spend that time. Like people doing Android, you're probably going to spend 8 hours just setting up the system and compiling it, right? So you're halfway there already, right? So yeah, so now you know kind of like some form of, and if you spend more, that's fine, because we still have the first part, you should learn something. So spend time until you think you learned something. Okay, I know these are very, very fussy guidelines, but I don't want to like, no, you can't do that issue, you can't do that issue, because you're all at different levels, and what's learning for you might not be learning for someone else, and stuff like that. So I try to be a little bit flexible in this. And in the end, when it comes to grading and examination, we have the home exam, and then everyone will be doing the same anyways, right? And the home exam is like based on this whole coding and refactoring and prioritizing and designing and stuff anyway. So I think that's a very good way of summing up everything you learned in the course. Any questions? Okay. So modifiability. Let's skip that one. I think I've mentioned modifiability several times already, because it's such an easy thing to explain. Like, we want our code to be very easy to modify, quick to modify, so it doesn't take a lot of man hours to modify, flexible, etc., etc. So we want to keep the cost and the risk low when making changes. We don't want to introduce new bugs whenever we make a change. We don't want to have other things break when we make a change, right? So again, take a few minutes to discuss or consider modifiability for Google Mail. And again, pick one thing and ask yourself, like, what should be modifiable, when and why do you think this would be modified? Who do you think wants this to be modified? And how do you measure whether you design the system to be modifiable in this particular sense? Okay, so 2-3 minutes, something like that. Okay. Do you have any suggestion on what should be modifiable and the following up questions? Anyone? Interface? Do you mean graphical or protocol type interfaces, API interfaces? Visual. Yep. And why should this be modified along the way?
So people like menus on the right.
Okay. Yeah, certainly. Okay, so we were talking about visual interface, user interfaces. The customizability of that, themes and GUI updates, whatever. Functional update. Yeah, functional update. You need to edit the interface. You might have to move things to the right side to fit something else, or you might want to update that. Yeah, certainly. And I think we already answered who. So who might be the developers, or it might be the customer, the user, who might want to do their own customization, personalization. But it also might be the developer who needs to add new functionality to it, so they will automatically have to update the user interface as well. It might be business requirements that actually change, because suddenly you might have to add some form of advertisement somewhere, which means you also have to affect the user interface, right? Okay. And how do we measure whether we made this modifiable or not? Anyone? Time is money, right? So how much time do I actually need to spend to modify the interface? How complex it is? How many other things do I actually affect? If I change this button here to move it over there, do I actually break something else, etc.? So that is certainly a thing. Can I have one more example? Anyone? Okay, so we're talking about, yes, absolutely. So I'm just repeating. So in general, with new possibilities and new technologies, new ways of doing things, we might need to update the service to include those new features or to optimize for new technologies. Certainly. I can definitely see that being a thing with new mobile devices. I mean, desktop devices have been fairly similar the last, a long time, although we've had HTML5 the last couple of years, right? Which meant we had new possibilities. But for mobile devices, I see new technologies being introduced into the devices themselves, which means that mobile clients may suddenly be easier to use, or you can start using gestures or voice commands, and etc., etc. So those, if you want to build those in, you may have to adapt some plugins or add some features to your mail clients, right? But also to support this on the back end. Maybe even use, is it Android, is it Alexa for the voice command thing? I think it's Alexa, right? So you might integrate that into Google Mail to read out your emails or whatever, now that they actually have such a feature. So there are many things that you could include or add, or features you can change as capability of devices and technology increases. Alexa is Amazon. I don't know which one is for. It's something A, I think. Not Adrian, or it's Alexa, Amazon, and then it's something else. Whatever, it doesn't matter. You understand what I meant anyways. Okay. So going to this overview of source, etc. So we already talked about end user. We talked a little bit about the developer. Maybe the system administrator want to make a change of the system. But we even have like business people, salespeople, etc., coming in and wanting to make a change in the system. And we want to add or delete or modify some functionality, or maybe even change the quality attributes. So maybe for a certain customer, there might be ease of use might be the priority function. For another customer, it might be quality of service. Another customer might be performance, right? So you might want to change between those. I think for Google Mail, I think it's all three, but maybe there's a special focus on one of them for some customer. Artifacts, things that you might want to affect with this: code, data, interfaces, components, resources, configurations, etc. There are lots and lots of things. Environment, it could be at runtime, it could be at compile time, build time, initiation time, design time. I think if you can do as many of the build in as many of the flexibilities in design time, it's better, of course. If you can make sure that you have late binding, for instance, for certain new features, if you can add plugins and add-ons, etc., that helps make it more modifiable in the end. And any way you can make it more modularized to make them separate, I think it's better. I will come into that again when we talk about tactics. Response, well, it's fairly straightforward. You make the modification, you test the modification, you deploy the modification. Very, very simple. You might want to update some documents, maybe design documents, etc. Or at least report the change somehow. We talked about this before. How to maintain the architecture to prevent code rot. I'm quite curious why they didn't include that here, because the whole code rot thing comes from the book as well as a concept. So I think it should be there as well. How do we measure whether we actually made something modifiable? Well, we can look at the code we actually need to modify, right? How big is it? What's, how many lines of code or the number of classes we need to change? How many, what's the size of everything? What's the complexity? Like if we have a really big or complex communication flow, do we actually affect something else somewhere? Do we break some other systems? All those things. If we can keep those down, we probably have a better modifiable system. Effort, calendar time, money, so those are all three very connected, right? Well, I mentioned this one. Defects that we introduce by making a change. Like if we actually introduce bugs, that's a bad thing, right? Okay, I think these are fairly straightforward. So, planning for modifiability. We need to ask three questions. What can change? What's the likelihood of the change? When is the change made, and who makes it? Now, I would like to stop a little bit on this and discuss something that I learned quite recently, the painful way. So I have two companies, right? And one of the companies, we are currently developing services for people with dementia or for nursing homes to help staff and improve the quality, etc., of care. And we actually hired a consultant to do parts of the system because we have no employees ourselves at the moment. And of course, I wasn't that involved in, actually I wasn't involved at all in the architecture because there were some, let's ignore the drama, okay? So there were controversies in this, but I did not involve myself in the architecture. But in the end, we couldn't really use that much of the code that was generated. And the reason was not because the code was bad, but the person who did make the requirements was very, very keen on making everything so very, very modifiable and flexible that in the end it became so very, very complex. I mean, there were even support for changing the name of our county council. Like, how often does that happen? I mean, how often will we change from Norrbotten to something else, right? Like, that will never, I mean, it might combine Norrbotten and Västerbotten, but it's like once in a lifetime, right? But there is support for doing such changes in this framework that was developed, right? So it's so super complex, and the database, the tables and everything is super complex. And you go back to consider what's the minimal viable product. That's the concept. Like what's the minimal thing we can do and create to actually get some sales done, right? So modifiability is not always good. I mean, yes, it's always good to have modifiable code to some extent, because modifiability sometimes adds complexity as well. So I think these questions, before I actually had this experience, I guess I could have guessed that it could happen like this. But before, I always mentioned or talked about like, oh, modifiability always great, right? And make as much as possible modifiable. But I have to stop myself a little bit now, and rather than just saying everything should be modifiable, right? Ask yourself, what will change in the future? Not even like the future in 10 years. Like, what will change in the next 2 years or next 6 months? Like, for the time where we're actually supporting this product, if making something very modifiable adds so much development time that it's not worth it within the support frame. Like if I'm going to support the product for 1 year and making it modifiable now takes me that many hours, but if I were to not make it modifiable now and change it later on, it will only take that many hours, then don't make it modifiable because I can change it later. And you get it out quicker because making something not modifiable is a lot quicker. It's a lot easier to design. Typically, not always. So ask yourself, what can change within the time frame of your decision, you decide? And how likely is that to change? How likely is it for Norrbotten to change name? Not very, right? And when it's time to make this change, will you do it? Will someone else do it? Because if someone else will do it, then have you actually documented your structure properly? Have you reduced the dependencies on other modules? Have you reduced the complexity of communication to make it easier to make it modifiable later on? Like, have you done what you can with simple means? So I think those questions are very relevant. Okay, we're going to have a short discussion again about modifiability tactics. I know there are 4 lines here. You can kind of ignore that because the 4 branches just discuss tactics in general. How do you make code modifiable? Okay, go. Okay. We have one suggestion from Koleftio, adding attributes when needed. Absolutely. I would like to ask the follow-up question. What kind of attributes are you thinking about? Feel free to start typing and I'll ask the people here. If you have, you can just ignore it as well if you don't want to. Okay, any other suggestions from the room? How do you make code modifiable? As modular as possible, absolutely. Separating concerns. This is rather coupled with coupling, right? Do you remember what we said in the previous course? Weak coupling, high cohesion. So those are definitely things to look out for. Like, if I use inheritance, I'll go through this example again, so you just hammer it in, right? If I use inheritance, if I make a change here, if I make a change in the parent, I affect the children as well, right? Meaning I might introduce bugs whenever I make a change. There is a benefit as well for this. Like if I have inheritance, like if I have a database module which handles all the data management, right? And the parent is doing this, then if I make a change in the parent, then like if I change the database, I only need to make a change in the parent and everything else fixes itself, right? So there are benefits and drawbacks, but you have to be aware of it. And typically you should favor composition over inheritance anyways, and aggregation over composition. Should I repeat what's aggregation and composition? Some of you are nodding. So composition is when your class initiates or instantiates something else, right? Variable car equals new car, right? In your class. If my instance dies, so does this car, because it lives and dies with me, right? So that's composition. It has semi-weak or strong coupling. Inheritance is, of course, I am a blue car, I'm a subpart of car. Like if car dies, so does everything else. If the car is modified, so am I, right? Very high coupling, very strong coupling. And aggregation is basically when you receive a car as an argument. The car lives on its own somewhere else. And if I die, nothing happens with the car. Only I die, right? So those are the difference. So, of course, aggregation in this case has very high separation between things. They live on each other on their own side, right? Okay, so that is for composition or for coupling, and it's the modular thinking. If you create something modular, then typically you will design for coupling, for low coupling and weak coupling as well, or separating concerns. It also has to do with cohesion. So cohesion was this whole thing, like one module does one thing or one class does one thing, right? So you couple you group certain behavior into one entity. So that is also making things modular, making them independent of each other and making it partly easier to understand what's going on here, but also separating concerns so they are doing their own thing. So if I need to modify the tires of the car, I don't need to go in and modify like the dashboard, right? They are different things, different modules. I'm making very, very simple and trivial examples, but I hope you understand anyways, like I separate concerns. So that's coupling and cohesion. Those are very, very basic ones. And separating concerns, any other suggestions? On modifiability, yes.
If the project is very large, you could introduce scripting language to ease the workflow. Also, if there are differences in very complex matters and more simple matters, and perhaps push some scripting language to utilize the more simple matters so that they can be worked on.
Okay, I'm going to repeat. So if you have very, very large projects, you can introduce some scripting languages.
Yeah, and compare if there was some scripting part, but you could do this as well.
I know what you mean, because I know now the name of this then, right? So what you are saying is basically deferred binding. You are saying that rather than making change on compile time, you introduce some scripting language that you can make change at runtime, kind of.
Yeah.
Yes, certainly, and that's called deferred binding, and that's in this slide later on.
All right.
I'm just trying to match it to things here, right? So yeah, it's called deferred binding, or that's late binding or whatever. But it's part of that, right? Because you scripting instead of, yeah. So you need to, but in that case you need to follow certain protocols or interfaces or styles, etc., or syntax, semantics and stuff, right? Okay, I think we start discussing now. Okay, reduce size of a module. Like anything that you can make less complex is good for modifiability, right? And you can do this by splitting the module in smaller pieces. Again, we talked about making things modular, but we can make it into smaller modules, so they are all a little bit more separated. Now there's a trade-off here again. If they become so small that it becomes complex instead, that's a trade-off you have to think about. But if modifiability is the key concern, then maybe that's what you need to go for. But if there are other quality attributes, you need to weigh them together, right? Makes sense, right? Increased cohesion. Well, we basically talked about that, right? Making sure that one class or one module does one thing to separate concerns. Reduce coupling. Well, we can use encapsulation to make sure that we safeguard inner behavior. So outside or communicating components will not change your internal state unexpectedly. So you have control over the change of states, you control over your internal structure, etc., etc. You can also hide complexity that way. Yeah, so basically it's all about controlling what's being changed, controlling communication, controlling internal behavior, controlling variables, etc., etc. You can use an intermediary. You can use like a publish subscribe method to communicate with information, and that acts like an intermediary in between. We talked about that in the previous interoperability as well, where we have an intermediary for hiding the complexity of the underlying system. You can do the same here to reduce the dependencies between two modules. I think this is worth explaining a little bit further. So if I have an intermediary, if I have like a facade, there's actually a facade design pattern, right? I can change anything underneath without affecting how other components work, as long as they all conform to this intermediary, the interface that I specify, right? As long as that is still true, if that does not change, if the interface does not change, I can change anything underneath to work in any other way. So I can actually reduce the number of bugs that appear when I make a change. As long as I still provide the same interface, as long as that doesn't change, everything else can change underneath. Of course, the behavior and stuff like that as well. The end behavior, the interface behavior remains the same. Restrict dependencies. I think we talked about that as well. It has to do with coupling, how much I dependent on others. Refactor. So workshop 3 is going to be on refactoring, and the programming part on the home assignments is going to be on refactoring. Basically, this part of the code does not utilize common behavior, for instance. Like we have this database component, and then we have a copy of that database component over there. So when I have changed the database, I need to modify in two places. Why? Like, why don't we combine those to one place, right? That is actually also abstract common services. So if actually that is abstract common services. things that have a commonality that partly is the same. Try to combine that, try to utilize them, right? In the same way, you don't need to make the same change twice. In the refactoring lecture that I'm going to give in a while, I'm going to give you the nightmare example of when this is ignored. But I'll save it for that lecture because it's pretty funny. Yeah, but any other way, whenever you have strong coupling, you might want to refactor it to have weaker coupling. Whenever you have lots of complex communication or dependencies or high coupling or whatever, there are lots of things you want to refactor to improve it. Oh, and defer binding, that's what we talked about earlier. When we want to modify behavior at runtime for some reason, or we want to make smaller changes, we want to customize something, we want to add some features of functionality or change some feature of functionality. If we can make it so modular or so, if we can define the semantics and syntax for making this change at runtime, then it's highly flexible. Then you can even make, then you can even ask third-party developers, just make this interchangeable module or this script. Just add the script and you can add a feature or make an add-on or whatever. It's very, very simple. You don't need to recompile the code. There's also safeguards your code, right? You avoid adding new bugs because nobody's messing with your internal structure. So it's very, very safe in that sense. And then we can skip lots of slides. Okay. The checklist. Allocation of responsibilities. Basically, again, consider what can change and why. So there are people from different parts of the organizations that are going to want to make changes. There might be, as we said before, technical features or technical possibilities that make you want to make a change, right? But there might be legal issues, like you're not allowed to use that framework anymore. We've been sued because whatever, it's too similar to something else. I don't know. There might be lots of things that might cause you to change your structure. Social. I'm going to skip that one because I don't have a good example in mind. But there might be social influences on the changes. Business, certainly, if there's a competitor that is releasing something similar, maybe you want to actually increase your functionality set to have an edge on them. Or you might have a better selling point if you design it like this or whatever. If you have red color instead of blue, I don't know. Customer needs, of course, it's going to change the requirements and they're going to change behavior and features and stuff like that as well. So that's why you do all this requirements engineering, right? In the beginning, to figure out what should we do, and you try to keep this iterative because changes will happen, and you want to figure out what can change so you know what you need to make modifiable, and not change Norrbotten to Västerbotten, I don't know. Okay, what responsibilities need to be added, modded for change? So if you are adding it, or if you're making a change, if you're adding something, does this change the internal structure, the communication behavior, the responsibilities of parts of the code, even the team? Are there changes in the team that needs to be made? Maybe there's a database guy that only works databases 2 weeks of the year and the rest of the time is doing something else, right? Do we need to make personnel changes within the structure as well because of possible changes in the future? And what other responsibilities are affected by the change? Like if I make a change here, does that cause the UI people to having to make a change as well? Because I added a feature or whatever. Coordination model. Functionality and quality. So what can change at runtime and how does that affect how we coordinate, how we communicate between modules, etc. If there are any changes to protocols and communication paths, and of course we want to reduce coupling, for instance, by making publish subscribe services, which is a communication model. Data model, to make sure that we have somewhat flexible data management and data handling. Try to find appropriate abstractions for that, for operations, etc. I think it's quite common for people to use, XML or JSON and stuff for that, for sending data back and forth, because they're all somewhat flexible and standardized, right? To help with data management and so on. And we have very similar, like people like SQL or NoSQL or relational database. There are standards that we try to use that are commonly used, that are easy to modify, or somewhat easy to modify. And whenever we want to make modifications to the way we handle data, the last one here, we try to group the behavior. So if we need to make a change for the data, that also, so you don't need to make, so you don't want to make how this data is being managed at several places. You want to make it, they change once. You don't need to group the behavior into one function or one method, right? Makes sense to me, at least. Mapping amongst architectural elements. Well, defer binding, we talked about this, to help mapping decisions. Resource management. Are there any resources that actually changed due to modification in the code? Any resource limits, like if I have bandwidth limitations or data access limitations, if we have high load in certain areas of the code, will that change as I make modifications? Are the requirements still enough, or are the resources still enough for the system requirements? Like if I defined, like you need this and this much bandwidth, or you this many connections to the database, are they still the same after you made the change? So you need to update those requirements, maybe. Binding time, don't overdo it, because you may have complex or unknown dependencies, etc. You can also consider the cost of deferring binding like this, because there is a complexity with it. There is, you may introduce faults as possible, like if people are doing poor scripting, will that actually cause some breaking or some bugs or whatever? Or is this safe enough? Is it time consuming to add these type of scripts add-ons or late add-ons in the end? Does it affect performance, speed and communication flow, etc., etc.? Things to consider. Choice of technology. Certain technologies have easier modifiability than others. If you pick a framework, for instance, do you have source code access, or do you have possibility to override certain functionality? Otherwise, many cases when you pick a framework, you're kind of locked in with those features, right? Like this is what you have to use, and that sets the standard for many of your other things. And you may not be able to modify everything. Some things you may be able to modify, but you should consider that. Like if you identify that the network protocol will be modified along the way, we're going to adapt to 5G or 6G or whatever, then if you pick a framework that is, maybe it's got an active community, so it's going to be modified on its own, right? Or maybe it's a late or an old project, and you know they're not going to adapt to 5G and they're not going to adapt to 6G or whatever. Then maybe that's not the best framework to pick, unless you can add your own features. But then why did you pick that framework? Because you need something else, right? So do you have source code access? Do you have hardware support for modifiability? Sometimes you want to actually affect the way hardware looks or appears, or the functionality of the hardware. I guess for many software developers, that's not the big issue. But in my company, for instance, we develop our own sensors because we need to look certain ways. We need to access to the source data, and it's basically like an accelerometer stuff. Unfortunately, all these Fitbits and Microsoft Band and stuff like that, they put the data in their servers. which means they own the data kind of, and Microsoft even have in the table in their TOC, no? Their contract basically says you're not allowed to data mine raw data, which is useless for us basically. So we make our own sensor just to have access to the raw data of galvanic skin response sensors and accelerometers and stuff like that. And by doing this, we also added other sensors because they might be useful, like oximeters and stuff. So we figured out like this hardware does not support our modifiability needs in the future, so we made our own. Okay. Any questions? Then thank you for today, and have a good lunch.